In this video, we will be discussing strategies for solving problems involving maximizing or minimizing quadratic functions. First, you must read the problem carefully to determine which quantity is to be maximized or minimized. Then use the conditions of the problem to express the quantity as a function in one variable. Rewrite the function in the form f of x equals ax squared plus bx plus c, and calculate negative b over 2a. If a is greater than 0, f has a minimum at x equals negative b over 2a. This minimum value is f of negative b over 2a. If a is less than 0, f has a maximum at x equals negative b over 2a. This maximum value is f of negative b over 2a. Here's an example. Among all pairs of numbers whose difference is 10, find a pair whose product is as small as possible. What is the minimum product? We must minimize the product of two numbers. P equals x times y. P stands for product. X and y is a possible pair of numbers. Now we must express this quantity as a function in one variable. So x minus y equals 10, we have to solve for y. Negative y equals negative x plus 10 because we subtracted x from both sides. Then you divide by a negative 1 and get y equals x minus 10. Now we substitute x minus 10 for y in p equals x times y. So you have p of x equals x times x minus 10. Now we have to write the function in the form f of x equals ax squared plus bx plus c. First we must do the distributive property. Distribute the x to the x and the negative 10. So you get p of x equals x squared minus 10x. A equals 1, b equals negative 10. Now we must calculate x to find the location of the minimum value. So x equals negative b over 2a. Our b is negative 10, our a is 1. So we have negative 10 divided by 2 times 1. Since 2 times 1 is 2, and negative 10 divided by 2 is negative 5, and these two negatives here make a positive, x equals 5. So with this question, we have learned that to have the minimum product, one value, x, has to be 5. Y equals x minus 10, which equals 5 minus 10, which equals negative 5. The number pair would be 5 and negative 5, and the minimum product would be negative 25. Now we're going to do an example of maximizing. You have 100 yards of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? First we must decide what must be maximized or minimized. We are maximizing the area. Dimensions x and y. Area equals x times y. Now we must express the quantity as a function in one variable. So 2x plus 2y equals 100. We are going to solve for y, so we must subtract 2x from both sides and then divide by 2, so y equals 50 minus x. Now we substitute 50 minus x for y in the formula a equals x times y. So a of x equals x times 50 minus x. We must distribute the x to both 50 and negative x, and we get 50x equals negative x squared. A equals negative 1, b equals 50. So now we're going to calculate x. We have negative 50 divided by 2 times negative 1. 2 times negative 1 is negative 2, so this equals negative 50 divided by negative 2. 50 divided by negative 2 is negative 25. These two negatives make a positive, so it equals 25. In order to have the maximized area, one value, x, has to be 25. So now we're going to plug 25 in and solve for y. Y equals 50 minus x, which equals 50 minus 25. So y equals 25. In order to maximize the area, the dimensions have to be 25 yards by 25 yards. The maximum area would be 625 square yards.